Hello everyone. Today I will introduce our work. VOSR, a vision-only generative model for image super resolution. The key question behind this work is simple. Do we really need large text-to-image diffusion priors for high-quality generative super resolution? Or can we build a strong VOSR model directly within the visual domain? Let me first give some background. Early generative VOSR methods were mostly vision-only, such as VOSR3, VOSR-DIFF, and raise shift. These methods directly model image restoration from degraded inputs after stables are. However, many real-world VOSR methods started to adapt pre-retrained text-to-image diffusion models. This brings strong generative priors. But it also means that VOSR is built on top of a general-purpose T2I generator. As these generators become stronger, more performance gain may come from the backbone itself. So we want to rethink the problem. As an independent restoration task, what kind of model does VOSR really need? Our motivation comes from the difference between VOSR and T2I or T2I generation. In text-to-image models, text usually plays two roles. First, it tells the model what to generate. Second, it tells the model how to generate or edit the image. But in VOSR, these two things are mostly already defined by the task itself. The content comes from the low-quality image. The structure also comes from the low-quality image. And the goal is clear. Restore it from low quality to high quality. So we want realistic details. But we do not want the model to change semantics, alter structures, or hallucinate arbitrary content. Therefore, VOSR is not open-ended image creation. It is an input-constrained and restoration-oriented task. This motivates us to build a vision-only generative VOSR model. Here is the framework of VOSR. Given a low-resolution image, we construct two types of visual conditions. The first one is a structural condition, extracted in the VAE latent space. It preserves spatial layout and low-level structure. The second one is a visual semantic condition, extracted by a pre-retrained vision encoder such as Dino. This provides high-level semantic information, but it is still fully grounded in the input image. Rather than coming from text, we then inject these two conditions into a diffusion transformer. The structural condition helps maintain fidelity, while the visual semantic condition helps resolve ambiguity during detailed generation. Another important design is our restoration-oriented guidance. Standard classifier-free guidance uses a fully unconditional branch. But for VOSR, completely removing the LR input is not ideal, because the model would need to learn generic image generation from scratch. Instead, we use a partially conditioned branch. It keeps weak LR structural cues while removing semantic guidance. In this way, the guidance direction is still anchored to the input image, which is more suitable for restoration. We also introduced the SCREE and VOSR benchmark. It contains diverse real-world images, including people, buildings, natural scenes, text, and complex textures. These cases are challenging for generative VOSR because they require both realistic detail synthesis and strong structural fidelity. This benchmark helps us better evaluate whether a model restores faithful details or introduces hallucinations. Now let us look at performance, efficiency, and training cost. Compared with T2I-based VOSR methods, VOSR achieves competitive or better perceptual quality in both multi-step and one-step settings. At the same time, VOSR is much more efficient. More importantly, its training cost is significantly lower, roughly 1/10 of representative T2I-based methods. This shows that high-quality generative VOSR does not necessarily require large-scale, multimodal pre-retraining. Quantitative results further support this conclusion. Across LSDIR, SCREE and SR, and our EA-LSR, VOSR performs strongly on perceptual metrics. Compared with previous vision-only methods, it brings clear improvements. Compared with T2I-based methods, it remains highly competitive. The main takeaway is not only that VOSR achieves good numbers, but also that a vision-only model can balance perceptual quality, fidelity, efficiency, and training cost. The visual results show the difference more clearly. Some T2I-based methods can generate sharp details, but they may also introduce structural errors or incorrect text. For example, bridge structures or text regions can become distorted or hallucinated. VOSR produces realistic details while preserving the input structure more faithfully. This is exactly what we want from SR. Not free-form generation, but reliable restoration under input constraints. To summarize, we propose VOSR, a vision-only generative framework for image super-resolution, by combining visual semantic conditioning, restoration-oriented guidance, and one-step distillation. VOSR achieves strong restoration quality with better efficiency and much lower training cost. Our results suggest that generative SR can be high quality without relying on multimodal text-to-image retraining. Thank you.